Hello and welcome to Sean White's Solar and Energy Storage Podcast. Today we have Tyler Hortin, who is the president of Lion Energy. Roar, Lion Energy. Okay, Tyler, let's hear a little bit about yourself.
Sure. I've been in the solar and storage space for about 10 plus years. At Lion Energy, we really focus on the storage, and we try to provide solutions that customers can use to be able to maintain and optimize their energy usage. We're a company that offers a handheld product, a portable product, and we also offer residential, commercial, and even utility-sized products. We try to offer best in class in each area that we go into and offer the right products for the right people and try to give the best products that we can, value that you can buy.
That's pretty amazing. So I know that you have very small batteries too, which is interesting. And so you go from watt hours, do you go up to megawatt hours?
We do, yeah.
From watt hours to megawatt hours. Wow.
Yeah, we could even do gigawatt hours.
Watt hours to gigawatt hours. That's about as wide of a range as I've ever heard of.
Yeah, we have a system approach, and we try to offer really good systems. All of our products are designed and maintained to make it easy to add storage to whatever application you have.
So maybe what I could do is I could start off with a phone charger and then just keep adding to it until I have the world's largest grid-tied battery system?
Absolutely.
Okay. Just want to be able to scale up. That's the way to do it. One thing that I thought was kind of interesting is just the name of your company, that probably a lot of people know that Lion would be more like Lithium-Ion. But also what I thought was cool is that lithium is at the top of the periodic table if you ignore the hydrogen and helium, where this energy is really coming from. It's a little bit of fusion, hydrogen fusing into helium, E equals mc squared, but we all understand that really well. And then you've got the lithium, and so it's the lightest metal too, and it's sort of magical how it sits there on the periodic table, and it's just made for energy storage. So that's pretty cool. And then I know too that it seems that everybody's talking about lithium iron phosphate, and I'm pretty sure that's what you're using. Maybe I'd even ask you, because a lot of times people are talking about cobalt and all that kind of stuff and how it's hard to get. And so where do you get the iron and the phosphorus? I know that there's more iron in Earth than any other element by weight, but it's really deep down. Have you been to the core of the Earth? Is that where you're getting it, or where do you get it?
So iron is actually not a huge piece of the LFP chemistry. It's primarily lithium carbonate and the two different types of lithium and how you put them together. And then graphite is a big deal with us. And lithium is actually one of the most available resources, and it's all over the place. It's just a matter of extracting it efficiently and effectively. And we're working with several companies to bring that to the US. We have many great relationships to be able to bring all of that supply chain here in the US. In fact, the Inflation Reduction Act has helped to expedite that. We've definitely benefited from that. And we are trying to find great partners to work with to be able to get all of that to a US supply chain.
Great. I know that iron, which is Fe on the periodic table for ferrous, that's the F and the LFP, is pretty easy to come by.
Yeah.
Not a hard thing to find, not rare, not bad, all that kind of stuff. In fact, I guess that's why Mars is red, is because it's all rusty, and iron is a rust thing. So they need to get oiled up there and get rid of some of that rust up there, that fourth planet. And so we've got lithium, L, iron, F, and then P is phosphate. And so that would be phosphorus and oxygen. And we know where we can find oxygen, but where do we find the phosphorus? I know that actually phosphorus is a essential element for life, like part of the human body. So are you harvesting humans? Is that where you get it from?
Not humans, no. Canada actually has quite a bit of phosphorus. And even here in the US, there is some available. So
yeah, I know lots of humans here. And of course, I was just totally messing with everybody talking about harvesting humans, but it's just like super abundant. So it's not like we have a big problem with getting all of these things. I think sometimes people are thinking like, oh, we're going to run out of lithium or we're going to run out of all these materials. I know too that I've been reading in the news that they're talking about getting lithium out of the Salton Sea where the Colorado River flooded maybe something like 100 years ago and caused this environmental disaster, which was an inland sea, and then it got salty. But I guess you're over near Salt Lake, the Great
Yes.
Salt Lake, so you probably know about that. Do you have lithium in your neck of the woods too over there in Utah?
We do actually. Yes. We have lithium near the Great Salt Lake, and there's also mining tails that you get lithium out of. So this is just extra materials that you have
Uh-huh.
in the mining process that they are revisiting to
Uh-huh.
pull the lithium out. And I know there's an operation doing that in California. And I think there's one here in Utah also. But I think some of the confusion in the industry stems from the NMC batteries, the nickel and the cobalt, which
Yeah.
is
Mhm.
cobalt is conflict material where they use a lot of children mining and things like that. And then the nickel is under control quite a bit from certain governments. But the LFP chemistry is awesome because it's the safest chemistry on the market. And since we focus on storage based products, it is by far the best option out there today. It's most scalable, it's most affordable. And we focus a lot on life cycles and just making storage available, which also means affordable to those trying to put it on their systems.
Great, great. Okay. I've noticed like you had something that was interesting too, and it was a 12-volt battery with an internal heater. And how does that work? Does it just have a resistance heater underneath the battery and then the battery will heat itself when it gets freezing?
That's right. And it also has barriers on the outside of the battery. So all the heat is contained within the battery, but there is a heater there. And then if the temperatures, we also have a BMS that can sense how cold it's getting. And so we program that. We have a team of 50 plus engineers here in American Fork, Utah, and they are managing that BMS so the battery can heat when it needs to, and you can control it to keep those temperatures at the right level.
What would happen if you had a battery like that and it was dark and you were in Alaska or something like that, and you're not there at your cabin, and then it gets to be 40 below for a month? They're not going to have enough energy to heat the battery, so it just would go into a dormant phase, I would assume.
That's right. And it can be dormant. It's just when you want to use the battery that it needs to heat up for charging or discharging. And usually we have different criteria that create whether you're going to heat it up or not. And so we try to give the option to the user so that we have a great portable app that you can use to see the battery and be able to manage it when you're nearby.
That's kind of neat. So I used to live in Alaska in a cabin, and everybody there's off grid. They're using lead acid batteries. With lithium ion batteries, when it gets below freezing, you can't charge it and you can discharge it, but not as well. And then as it even gets colder, there's less that you can do. So that's kind of a neat option that you can just push a button and heat it up. And you might be like, oh, I'm going to make that battery turn on an hour before I wake up or something like that. Or I've got to charge my computer in an hour and then I'm going to heat the battery up, I guess, something like that, maybe.
Yes, it's continually improving. You can set with our battery, it does it automatically. When you try to charge or discharge it, it'll turn on. And then some future development I'd love to have in the app available that you can just push the button on the app and say heat up
Uh-huh.
battery and plan it out. And so I think that's going to be coming in the next few months. But
Great.
there's a lot of options. As long as you have the hardware there, you can control it the way that you need to.
Yeah, some other things that I noticed that were kind of neat. One of them was a generator hand crank. And that also reminded me when I lived in that cabin in Alaska, I'd have to walk a mile to get to the cabin. And I had this little flashlight that I would crank to see, and I wouldn't run out of batteries. And one time I saw some bear poop, which kind of scared me a little bit. And I was really happy that Crank made some noise to kind of keep the bears, let them know that I'm coming so I didn't sneak up on them. How does that work? You got a little dynamo in there, I guess, and
Yeah, it actually used rare earth minerals to create that energy, but it's not the most effective way to do it. But for short term, it's
Mhm.
definitely an option. I prefer solar for sure
Yeah.
over the hand crank because you can keep going with it. Hand crank, you're going to get tired, but it is something that several of our customers asked for. So we brought it to market.
So another thing I was thinking with the hand crank that would be kind of neat is to limit the kids on the screen time. Like they'd have to not be so lazy. They'd get to build up their wrists and all that kind of stuff. So maybe there's another application out there.
Yeah, that's a great idea.
Then I noticed that you have some lights, so you have a little bit in the way of loads. And don't worry, we're talking about the smaller stuff and we'll work our way up to the bigger stuff. And then you have marine batteries, and I have a sailboat, so I'm into that. What makes a marine battery different? Is it like ready to go dump into the water? Or what does
No,
happen if
yeah,
your
not
marine
not a lot.
battery gets
Yeah.
dumped into the water?
Yeah, it's not often. I mean, sure, it's water resistant, but marine batteries, you're also worried about the same things you are for like RV or your home or whatever. The barrier properties are important, but really, having lithium in a battery is the best option. Lead acid, it has like, let's say, 250 life cycles, whereas a typical LFP battery is going to be 3,500 plus life cycles. So you're going to get 10 times the life, which is a very important thing when you think about lithium. It is actually more affordable than lead acid. A lot of people associate lithium with expensive, and it's because the initial price is a little bit more than the lead acid. But the reality is, over the life of the product, lithium is by far the most affordable and most usable type of energy storage available. And so the key is to use the lithium that you buy. And that's very important to us when you think about even recycling at the end of life. Being able to use your lithium from beginning to end of life is a very important factor. I think because most of the lithium batteries originate overseas, there's less thought about the full life cycle of the unit, but it's very important to add recycling into the whole product life cycle when you're thinking about lithium and things like that. And we're very thoughtful in our approach to the full life cycle of the product.
Yeah, I know that they say that there's a lot of lithium in seawater. We just have to figure out how to extract it in the right concentration. So maybe when we're sailing around, we could just scoop some out, if we're running low.
It's a
So,
good thought.
uh,
Yeah, you can clean water out there, so you might as well scoop up lithium.
so the nominal voltage, which is the naming voltage of a lithium-ion battery that's lithium iron phosphate, is 3.2 volts. And then when you put 4 in series, you get 12.8 volts. And that's a little bit more than the nominal voltage of a lead acid battery. And so the ideal charging parameters are a little bit different. What do people do when they're doing something like that for their marine batteries? Do they just drop them in and they still work? Or do you find people figuring out how to reset the charging? I know that a lot of times with marine batteries, you just have like a regular alternator.
Yeah, usually we recommend just resetting the parameters on your charge controller. If it gets too confusing, you could get one that's specific to lithium, but usually it's available in most charge controllers to be able to increase that voltage. The other great thing about lithium is it charges at a much higher rate. You can have a much quicker charge, like a tenth of the time of a typical lead acid, and it can handle it typically. And especially if you're using the right type of cell in that product. And so a lot of that engineering happens certainly in the background is very important in the product.
Yeah, I know that they say one of the reasons why it's not ideal to just drop in a lithium iron phosphate battery into your car, say for instance, a car is designed for a lead acid battery, and so it does float charging. And so it's giving it this constant charge. And that's really good for a lead acid battery because it discharges as fast as you're charging it. But with a lithium ion battery, it's so much better. It doesn't self-discharge at that rate. And then you can overcharge it. And it's not so bad with a lithium iron phosphate, but if you had like a cobalt style NMC type of battery, something like that, and that NMC is lithium nickel manganese cobalt oxide, then you could overcharge it. And with the NMC, it could actually even perhaps in theory be a fire hazard, not so much with LFP, but it could make the battery wear out faster. It's probably good for people out there to know that too, but it's not like you can't do it. And then like you were saying, using a charge controller is the ideal way of doing things.
Absolutely. And also you have to consider the alternator in a car. The lithium batteries can take a much higher charge. And so a lot of the manufacturers of the alternators have planned on lead acid, which limits that. But if you put lithium in there, we found that sometimes you can overtax the alternator. So you need to consider that when you're doing that type of install.
Yeah. And I know even for a long time, people that were out sailing the seas would get an extra big alternator, and RVers and things like that, because they want to charge batteries so they can use them and not just to trickle charge them and only start the engine like most people do with cars. So there's people that are getting new alternators. Perhaps maybe they'll invent a special alternator that'll have some kind of lithium iron phosphate setting, and then it will have a little bit different in the way of charging parameters.
Yeah, they do have something called a DC to DC charger that you can connect on to that and be able to control the power that's going into that.
Yeah, and I know that my electric vehicle, and I think most of them still have the lead acid batteries in there. So you have like the big lithium ion battery, and then you have the small lead acid battery that's like the auxiliary battery that keeps your computer running and things like that. So you don't have to use the big battery all the time, just to keep a little small load going. And then your big battery will top off your little battery. And I've heard some of the companies now are switching over to a lithium ion, I think lithium iron phosphate battery for the auxiliary battery, which is kind of cool.
It is for sure. And it's just so much more reliable. And the great thing about lithium is it maintains that chargeability. When you think lead acid, you're losing, let's say it starts at 100% capacity. Day one, you're at 99%, 98%, and it goes down very quickly. Whereas lithium maintains that high level of charge. And so you can use it longer throughout the life of the product. And so lithium, you just have a much better experience. In addition to how many life cycles are available, it also gives you a better experience for all those life cycles.
Yeah. Yeah, I can't wait till they just get rid of all that lead acid.
Right.
We just have to design our things for that. And I think it'll happen.
Yeah, to your point, for the cabin batteries and things like that, it always makes sense to put in a lithium battery.
Yeah, great. So I noticed another thing that you had too that was interesting is the EMP bag. And I saw that on your website. So that, I guess, is for electromagnetic pulse. And so we're talking about prepper stuff here, which I always think is kind of neat, And so I guess like somebody has a nuclear bomb in space and then it goes off, it kills all the electronics. Is that?
That's right. And in that bag, we have like a copper mesh that covers the whole inside of the material, but outside of the bag. So you can put something in there and it absorbs it. It's mil spec rated. So we've done the testing to be able to make sure that it will absorb that. So you can put your sensitive electronics in there in the case of something that happens.
I'm sure all those billionaires with the bunkers, they probably have lots of those, huh?
They do. Sometimes I've heard people building an EMP around the house, which is super expensive, but is an option.
And is that sort of like what they call a Faraday cage?
Yeah.
And then another thing that I was thinking of too, with the smaller kinds of batteries, is there any people that you've ever heard of that would be able to like have something that you throw in your trunk to extend your range?
It's difficult, but yes, you could do a few miles, 3 to 5 miles, something like that. The EV uses so much energy and it's such a big battery. To get a significant amount of miles, it would take a pretty large battery. But
Yeah, like you maybe want 10 kilowatt hours or something like that,
yeah,
which is like a residential sized battery, but would kind of work. Another thing that you sometimes think of too is somebody getting stuck in an emergency. You see pictures of people that were stuck and they using even a generator or something like that just to get them going. And soon enough, though, they're starting to, even now, they're starting to come out with electric vehicles that you could plug into. So then you could jump the other electric vehicle.
yeah, that's right. And it takes thought
Hmm.
in electric vehicles. I have one, and you need to think about where you're going and when you're going to run out for sure.
Okay, so let's start talking about some of the bigger batteries. And let's see, I see we can work our way up. You have tiny home, and that's sort of like, I guess, marine sized applications and things like that that we've already been talking to, I guess.
Yeah, so we have a product called the Safari. It'll handle like a tiny home. It also handles like shore power for like a boat or RV. And you can just plug it into there because it has a 6,000 watt peak and 3,000 watt continuous. And it has a decent sized battery internal and then an expansion pack which puts it up to 4.2 kilowatt hours combined. So that's a good option for many, and it's portable, which is
Mhm.
great. And the reason we do the expansion pack is to keep it lightweight enough that you can move it to where you need to. It's great for construction
All
and
those
just any.
solar installers up there on the roof with their power tools and all that.
Yeah, for sure. And it's a really great solution. I keep mine on my workbench in my garage
Mm.
for all those, and I'll just throw it into my Sequoia when I go out and bring the power with me.
So when you
So,
said shore power, that's what the word they usually use for like RVs and boat is because the word shore is in it. And when we're talking about shore power, typically we're talking about you can charge your battery from the shore, but you can't export to the marina or anything like that. And
right. Yeah. This could be charging or running your boat or RV. It has enough 6,000 watt peak, 3,000 continuous that will do that for you.
mhm.
And obviously, you have the limitation of the size of the battery, depending on what you're trying to run, but it can run even AC and things like that. AC obviously is a higher load. So you have to be careful about how much battery you have. But a lot of times, even in RV, you don't need AC all day long, or else you can also put solar panels out. And we have an extension cord so you could put RV in the shade and you can put your solar panels out in the sun and they're portable and everything. And then there's the extension cord that goes into the Safari so you can bring that power in with you to the RV.
Cool. And then also you said it's portable. So I guess in theory, you could have a boat and an RV and you could bring it to both of them and you don't need two of them. Might
That's
have to
right.
be able to secure them a little bit, figure
Yeah.
that one out. So that'd be kind of nice. So now let's talk a little bit about putting the energy storage system in a building. So now we're talking about energy storage systems and UL 9540 and stuff like that. Are you doing the UL 9540?
Yes. 9540 and 9540A
That
safety rating.
Yep, yeah, and the 9540A is called large scale fire testing, even though it's also for residential systems. If you wanted to put a couple of batteries in your house and they would be close to each other, closer than 3 feet, you definitely would need to have the 9540A test. It's just a standard, but it is different. It's a fire test, so they intentionally make it burn and then they see what happens. Unlike 9540, they don't make it burn.
That's the great thing about that 9540A. We engineer the product so that there won't be a fire. So even if there is an event or whatever, a cell that fails, and you can't predict the failure, but you can protect the product from having a catastrophic failure. And so all of our products are engineered to make sure that you don't have to worry about your house. We aren't going to burn it down or anything like that. And it's because of the protection that we put in the battery pack and the way we put it together to make it safe for the homeowner.
Yeah, so essentially what happens, I believe, is you have an energy storage system which has a bunch of little small batteries in it, and then they catch one on fire and see if the neighbors catch on fire and things like that, and see if the other energy storage system next to it catches on fire and want to make sure that it's not going to burn your house down.
Yes. And in fact, we use what's called a prismatic cell. So our cells are 280 amp hour. So pretty significant in
Wow.
storage. But yeah, so it's tested so that it doesn't pass from one cell to the other.
So
And
that's
we take care of that.
280 amp hours. Like if we wanted to do the calculation, I'm going to go 280 amp hours times the nominal voltage is 3.2 volts. And I'm going to get 896 watt hours, which is pretty close to a kilowatt hour. So that's a big cell.
Yes, we
Mhm.
have 14.3 kilowatt hours in our sanctuary product, which is what you would put on the home. So each battery is a pretty significant storage. And then with our sanctuary system, it's scalable. We do have the inverter separate from the battery. So you can have multiple batteries with each inverter and then multiple inverters to get to the size that you need. We can scale up from a smaller home to, we've had homes that are 10,000 plus square feet, and we can power those homes with that sanctuary product.
Wow. So you told me 14.3 kilowatt hours. So I took 14,300 watt hours divided by whatever I had for the amp hours, which is 800 and something, and I got 16 batteries. So you must have
Yes.
16 batteries in there. So that's just a little bit of math there. And so we want everybody to brush up on their math right now. And so that's pretty neat. And then you can scale them up and put multiples, and you got like these big giant houses that billionaires live in and stuff like that. It must be like the Faraday cage guys with the copper around their houses, because you never know.
Yeah, the other cool thing about having large format storage is there's not as many failure points. And so when you think about those small cylindricals, you're going to have hundreds of those in each battery pack. And all of those have to be connected in some way. And so having 16 versus hundreds, it's less likely to have that failure point.
Yeah, less connections between cells and all that. That's a good point.
Yeah.
Okay, yeah. It sort of reminds me of the argument that people have when they talk about microinverter versus string inverter, more points of failure, or string inverter versus central inverter. Like you have more points of failure when the inverters are smaller and you have to get more of them. So you can say that with the battery cells.
Yeah, our inverter is typically a string inverter. The other benefit to those string inverters, solar that goes into the inverter, is if you don't invert it at the solar panel, you maintain the efficiency because the panel produces in DC.
Mhm.
And if you're inverting it, there's a loss that occurs there. If you don't invert it and you use a string type setup, you go DC, and the battery is DC, obviously. So DC to DC charge is much more efficient. So when you're producing on the roof, putting it straight into the battery is really good because you only invert it once going out to the house or selling back to the grid or whatever to get it to AC. So you can do that.
So great. So your DC coupling, they call it DC interconnected system. They changed some of the wording in different versions of the NEC.
We also have what we call a generator port, but it also, if you do already have an existing solar setup that's AC, you could put it through that same port and still use batteries for your home.
Great. That's pretty neat. We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right. Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSean, that's solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show. So we were talking about residential. By the way, I was wondering what kind of inverter you're using, your own inverter? Do you use other companies' inverters?
Yeah, so we control all of our own equipment. So it is our inverter, which is important when you're taking the system approach for your products.
Great. Okay. And so you have to get all that stuff listed. And so when you're doing 9540, you're pretty much getting a battery and an inverter, and you're sending it in to get tested. So if you're operating your own inverter and your own battery, or it's coming from the same company, then you don't have to worry about working with other manufacturers and things like that. And I'm wondering too, for the residential, what are you doing for things like rapid shutdown? Just using some kind of DC shut off device up on the roof, something like that?
We do. Yeah, we use any of the available rapid shutdown buttons that are
Right.
out there. So,
Yeah. So yeah,
yeah.
there's a lot of different ones that work with different, any company that you're wanting to work with. So let's talk about some of your bigger batteries too. So you said you could go up to a gigawatt. You don't have a single cell that's a gigawatt hour, do you?
No. Typically, it's in that 280 amp hour cell,
Yeah.
just growing bigger and bigger. We have a product that's a cabinet that you can put on, which is unique in the market. I think there's not a lot of cabinet size. A lot of the companies out there go straight to the utility size products, but the cabinet is great because you can put that on commercial buildings and be able to manage your energy. And not only that, but it doesn't need solar to be able to optimize your energy. There's all sorts of peak charges when you're turning equipment on, and also energy shifting that's available in those states that have the different times of day that are more affordable. And your cabinet just sits on the outside and manages your energy going into your building, and you're able to optimize those rates that are coming into your building.
So when you say cabinet, how big is the cabinet? Do you have different sizes?
No, it's one size, and then you can put multiple, but it's about, I would say, 4 or 5 feet wide, and then probably 6 or 7 feet tall.
Okay, so it's about 4 or 5 feet wide and about 6 feet tall. Is that?
Yes.
Okay, great. And so if you have one of those, is that something that you're going to be putting inside a building, or do you put it in some container looking device, or how does that work?
Not a container. It is self-contained, but you would put it just outside of your building. But it does have HVAC, so we use air cooling on that device, or heating, depending on what you're trying to accomplish. But you would put it just outside of the building where the power would come in.
It's a good
and
idea,
just
just in case anything happens, it's outside of the building, and so you don't have any problems in the building. That's a big thing that people in the industry have learned over time too, is putting the energy storage system, especially when we're talking about like commercial and utility types of energy storage systems, outside, away from a building. And so if anything happens, they just let it burn out. But we know that is lithium iron phosphate, and it'll never happen. It'll never have that problem.
Correct. We have a lot of safety devices on that cabinet, so I'd be surprised if it burned up. But it also makes some noise, not significant noise, but you want to keep it outside of the work area.
Yeah, it's nice. And then you just put it outside. Yep. And then another thing that's happened too is a lot of these cabinets, would you say like the smaller one that you mentioned is a cabinet, but then you put it inside of something else, and you have a name for that?
We do also a container, and the container has liquid cooling, and it starts in the megawatt level. So like 1 megawatt, 2 megawatt. We go up to 4 megawatt in a 20-foot container.
And then also too, when you say megawatts, what about the megawatt hours?
Sorry. Yeah, the megawatt is typically 1, and then our 20-foot container can fit up to 4 megawatt hours.
Okay, great. So that would be like a 1-to-4 ratio, like megawatts to megawatt hours?
Yes. I mean, you can scale it back and do a 1-to-1 if needed, but yes, 1-to-4 is typically the way we would do it.
Kind of nice. Great. Well, I guess inside of these cabinets now too, there's all kinds of like fire suppression systems and things like that. Does yours work?
We have a fire suppression system. We also have several devices that sense different things in the cabinet to be able to understand the cells aren't performing the way that we expect them to. And then we can control alerts and things like that. So we don't necessarily have to go out to the cabinet to diagnose what is going on. We can understand what is needed. So if we do need to maintain that unit, we could send whoever the technician is with the right products to be able to bring it back up to working order.
So I know sometimes there's sprinklers inside of the containers. Not really containers, I guess. They're container-like. They're sized like a container and they look like a container, but they're not just like your generic container that's at the port. You open them from the outside. You don't go inside of them, right? These ones you don't go inside of. Like that's pretty typical for an energy storage system these days. And sometimes there's things like sprinkler systems. There's things that will release different gases that are non-flammable, stuff like that. And so what's inside of your container-like product?
Yeah, so we have a fire suppression within, which is required by code for sure. And I'm not exactly sure the material that sprays out, but it is meant for lithium. It's obviously not water, but
Yeah. Well,
so
actually,
yeah.
if you had a lithium metal battery, which is not really used for rechargeable applications these days because it's a little bit dangerous because you can get dendrites and explosions and things like that. And so that would have like the element lithium in it, and that would explode when it comes into contact with water. But with lithium-ion batteries, they even say to spray water on them just to cool them off.
Yeah, you're right. It won't spread because of the water like the NMC, but there is better gases that can be able to suppress anything much better with LFP.
Great. Yep. And so let's see, is there anything else about your batteries and things that we should be talking about?
Yeah, we have the full range of control. And the great thing about our systems is we have what's called the web app. So you can see your home or commercial building, you can see what happens over time. If you have solar, you can see what you're creating every day. You don't have to be in the house. You can understand, hey, I'm producing this much of solar. We also send alerts so we can tell you, hey, your production's down, go check your solar. Or we can tell you a storm is coming, charge up your batteries and all of those things. Or maybe you aren't optimizing your product, you want to optimize it better. But we give complete control to those that have our products, but give them a lot of information so that they can make those decisions. But then keep it easy enough so that if you don't want to get into that, we're able to help you to be able to accomplish the goals that you have. And so keep it simple enough, but give enough information so that if you do want to know more, you can find it.
So I also noticed that you have a very strong financial background. And a big thing is tax credits and the Inflation Reduction Act. And I bet you know a ton about that. And so how does it work for an energy storage system and the Inflation Reduction Act? And is there anything extra that you can get or anything like made in America or anything like that?
There is 30% is the base tax credit that is available to anybody. And then depending on the labor that you use for installation and then the US content, there's 10% kickers that you can get up to 70% if you get all the extra 10%.
That'd be nice.
Yeah, but the great thing is for like commercial and utility, a lot of times this is a business. And if you're taxed at a high rate, a lot of times you can depreciate these systems very quickly. As far as cash flow is concerned, you can make this extremely beneficial to your business. So even be positive cash flow because you can secure equipment funding and things like that to pay for it, and then use the offset that you're doing with your grid consumption and things like that and managing that to pay for the system. So a lot of people think it's expensive to get into these systems, but we found that if you set it up the right way and have a lot of the right methods in there, you can actually make this a very positive thing to your business.
So as far as getting greater than 30%, and I know that people talk about 70%. Another thing too is that with energy storage, you don't have to be connected to PV anymore. That's another new thing that happened with the Inflation Reduction Act. But like, how can people get up towards that 70%? And I don't think anybody's ever received the 70% yet, right? I mean, it's just we're such early stages and people are building factories and it takes a long time to build a factory. You probably know some stuff about that.
Yeah, it can be difficult. And the thing is, it's calculated. So, like, US content is calculated by the customer. And so the person that's putting it on their building, it's talking about the whole installation. So, all the products that you put on to that system qualify as a piece of that. And depending on the year you put it in, it's roughly 50% has to be US content, and then it's growing over time. And so that's for the 10% kicker. There's also a labor rule that you can get for the installers, that you can get another 10% kicker. And then there's two others that I'm not too familiar with that you can also add on to that.
I think there's one, maybe it's like if you do it at an old coal mine or something like that. Is it?
Yes, that sounds right. Yep.
And so there's some people that are doing renewable energy projects on coal mines in West Virginia, old coal mines out there.
Yes. And so that's the thing, is those other kickers are definitely more niche, and a lot of the people that are taking advantage of them are actually specifically going for some of those tax credits.
You mean you don't have an old coal mine? I mean, we all do, don't we?
I don't have one here in my backyard.
I guess that's it.
Yeah, they're shutting a lot of those down, but we do have a coal mine community that is coal mining not too far from us, a couple hours.
We started, you said something about getting materials like, was it lithium out of tailings? And so tailings are when you are mining for something and then it's the extra that comes out. So actually in the 80s, when I was a teenager, my dad had a rock quarry and gold shot up like crazy. And I was a gold miner for the summer. And I made some tailings. In fact, I might have been mining in the tailings that somebody else mined 100 years earlier or 130 years earlier. It was up in Calaveras County. And I got about an ounce of gold that summer, not bad for a 14-year-old or whatever it was. And, it was $800 an ounce, and do some inflation adjustments and all that kind of stuff. And so was that right? You said that was the tailings for the lithium that they were getting? And
yes.
What kind of mine was it? Was it coal or?
No, I don't think it was coal. It was something else. But yeah, those tailings, it's just a matter of how efficiently you can pull lithium out of it. Lithium is actually one of the most abundant
elements in the universe.
In the universe. Yeah. It's just a matter of how efficiently you can extract it.
Yeah. It's just not as rare as some people might think it is. Lithium's all over the place. Great.
Right.
And so we were talking a little bit about like Made in America stuff. And I know you have another organization that you're involved with. Are you guys building a battery factory? Is that what's happening there?
We are. Yeah, we are partnered with another company called American Battery Factory. And American Battery Factory is in the business of manufacturing the lithium cell. And so that 280, actually, it's going to be a 315 amp hour cell. And the great thing about American Battery Factory is they are focused on storage-based applications. And so the chemistry and the cell design is specifically done for energy storage. And we're happy to be a part of that. And we will be building ourselves a facility that will be very close to the American Battery Factory facility, where we will be able to take those cells and then put them into our products. So we'll be manufacturing those products in the same area down in Tucson, be able to deliver those to the US market.
Great. And so if somebody was using those cells, then would that mean they get the extra tax credit, another 10%?
Yes, that is right.
So we're talking about people using your equipment right off the bat, getting a 40% tax credit. And then if they're using prevailing wage laborers, we got a 50% tax credit right there. So that's a tax credit that pays for half of everything. So that's pretty cool. And I just want to make sure, are you getting prevailing wage? I'm just kidding.
Yes. We are.
I want to see your pay stub then. No, I'm just kidding. Yeah. So it's just pretty exciting, all these things that are going on. And it does take, how long does it take to build a battery factory? I mean, it's got to be a while.
Yeah, so we're expecting to be in production second quarter of 2025. And right now we're just building the building and the equipment is significant. It's a big investment, which is why it's so important to have the IRA, is to be able to help build this industry here in the US. In the past, when you think the chip industry, it started overseas, and it's primarily because the equipment is so expensive. But being able to have those types of industries here in the US is super important for us as Americans.
Yeah, and those battery or all kinds of factories are very dependent on automation and robots, I guess, too. So what happens when the robots go on strike? Is that like,
yeah,
I guess
robots robots never go on strike. It's great until AI takes over them. No.
Yeah, I know. Some good science fiction.
Yeah, that's the great thing about lithium. The best way to produce it is with those robots and fully automated. And that's here and also in China. So there is no benefit to having cheaper labor to lithium cell manufacturing. The only barrier to entry is just the expense of those robots. And so it's super important.
Great. Yeah, I remember when we went out to Salt Lake City, which is where your company is near, for the big solar conference out there. It was RE Plus, and I think, I'm trying to remember, was it the one that was in 2019 maybe? I think it was right before COVID was a big thing. Maybe that's where COVID started, just kidding. But I really enjoyed being out there, and I remember like renting a bicycle and riding the bike around, and it was kind of fun.
Yeah, if you love the mountains, you love skiing. I go skiing every weekend, so it's a great place to live for sure.
Great. That's probably where you make all your important decisions out there on the slopes.
For sure.
Yeah.
Yep.
I guess right now you probably have some snow out there.
We do. Yeah, a lot of snow. This is a great year for snow.
Great. Okay. Well, good. Let's see. Is there anything else that we should talk about or?
No, I just appreciate spending the time on our products and solutions that we offer. I think it's important that people think through their energy needs and proactively try and find areas to integrate these solutions into their life. It doesn't have to be expensive. In fact, it can save you money over time. And being able to add these storage products to be able to bring the grid to a more smart level is just super important. And distributed storage is very important to us as citizens. So I appreciate you taking the time.
No, I really enjoyed talking to you. And thanks, Tyler Hortin of Lion Energy. And also thanks for listening to this podcast. But let's see, one more thing is, how can people find out about you and Lion Energy?
Yes, you can find a lot of great videos, a lot of great content at lionenergy.com, LION energy.com.
Great. And your name is Tyler, Tyler Hortin, Hortin.
That is right.
Awesome. Thanks for listening to Sean White's Solar and Energy Storage Podcast. To find out more, go to Solar, SEAN. That's solarshawn.com. And you can find out there about classes, all these different places where you get all this great information, because we are in the business of education. That's right, sticking stuff to your brain cells. Get smart.